In these videos, we're going to look at probability. There's some notes that accompany this, but sometimes the notes of probability can be a lot more confusing than the actual kind of idea and the actual concept of it. I think it's quite a logical topic. The best way is probably just to look at examples and deal with things as they come up, and then use the notes alongside if you need a little bit of clarity on some definitions or what certain things mean. So we'll start with the more simple questions, and it gets a little bit harder. This is a big topic, it's an important one for the IGCSE. There's worth a lot of marks over various questions, from the easy ones to the hard ones. They're going to ask lots of questions on this, so it's one worth being good at. And it should make kind of logical sense as you think about it. So let's look through this question. So here's a 5-sided spinner. 5 different numbers, it's labelled 1 to 5. The spinner is biased. So biased, I'll do it in a different colour to highlight it a bit more. So biased, this just means that it's not fair. Okay, now a fair spinner would have an equally likely chance to hit every number. So if there were 5 different numbers, every number would be just as equally to hit, so you'd have a 20% chance. If it was fair, and 5 numbers, it would be just as likely, so it would be 0.2, 0.2, 0.2. Every number is 20%, which is 0.2 as a decimal, 20% chance of being hit. Okay, like a dice. If you roll the dice, the 6 numbers, if you assume the dice is fair, it's equally likely to roll on a 1, or a 2, or a 3, or a 4, or a 5, or a 6. They've all got the same chance. Okay, it's not like when you roll it, it's more likely to come out a 6. Okay, it's equal. For something that's biased, and this is important for the question, that means it's not equally likely to happen. So 1 is not the same chance as getting a 2. Okay, maybe it's weighted or something. It's not fair. You consider a coin fair because it's heads or tails. If you flick it in the air, it's 50-50. Okay, 50% chance of head, 50% chance of tail. If it's a biased coin, it might be slightly weighted in one way or the other, and therefore maybe it lands heads 70% of the time and tails 30%, and then it's biased. Sorry, that was my phone ringing. Okay, so that's how it works. This is a biased spinner. So you can see the chance of it landing on a 1 is 0.36. So it's higher than the chance of landing on a 2, 0.1. With probabilities, your probabilities must lie between 0 and 1. Okay, we'll just go through this a little bit more detail because it's the first question. Okay, where 1 is impossible for it to happen, and where 0 is impossible for something to happen, and 1 means it's certain that it's going to happen. Okay, so if something has a chance, a 1 chance is like 100%. Okay, 100 out of 100. It's always going to happen, whereas 0 is 0%. Okay, and somewhere in the middle we've got 50% chance, which is half and half, like a coin flip, half heads, half tails. Okay, if something is certain, it's always going to happen. Okay, like if you roll a dice, it's always going to land on a 1, 2, 3, 4, 5, or 6. There's no other number, it has to be that. So it'd be certain to land on one of those 6 numbers. Okay, the chance of it landing on a 7, on a 6-sided dice, is 0. It's impossible. It's never going to happen. No matter how many times I throw that dice, it's never going to happen. Okay, so that's how probabilities work. So they're always between 0 and 1. For a spinner like this, we've got 5 numbers. 1, 2, 3, 4, 5, as we've kind of mentioned here. Okay, but we've got different probabilities for each one. So they put them into a table. That's the chance of landing a 1, a 2, a 3, a 4, a 5. And what happens is, with this spinner, it's still going to land on 1, 2, 3, 4, or 5. There's no number 6, there's no number 7. It's got to be one of those 5 numbers. Okay, so it's certainly going to land on one of those 5. So that means the probabilities will always add up to 1. Okay, and these are the kind of most simple questions. It's worth 2 marks, but the probabilities must add up to 1. So the probability of it landing on a 5, this is our unknown value in the box. All we have to do is 1. So the probability of landing on a 5, and quite often we indicate the probability of something happening with a P. That just means the probability, and then the event happening, is getting a number 5. So the probability of a 5, we can write like this, is going to be 1 subtract all the others added together. Okay, because that's the chance of getting a 1, 2, 3, 4. So the chance of getting a 5 will be whatever's left over out of the 100% kind of chance. So if we add all these together, we get 0.46, 0.71, 0.86. So the chance of getting a 5 is 0.14, 14% chance. Okay, we can leave it as a decimal, we can leave it as a fraction, we can leave it as a percentage. All of those are probabilities. 10% chance of something happening is the same as 0.1, is the same as 1/10. And depending on what the question is asking, sometimes it's favourable to use a decimal rather than a fraction. We'll come on to that. Because we're given decimals in the question, I'm going to keep everything in decimals for this. Okay, that's how it works. So 0.14. So with these kind of questions, it's 1, 2, 3, 4, 5. It's got to be one of these. So they have to add up to 1 in total, because one of them is going to happen. If you spin this spinner, it's going to land on one of those numbers. So the chance of it landing on something 1, 2, 3, 4, or 5 all together is 1. So add them all together, take away from 1. In this case, we get 0.14. So that's the first kind of question they like to ask, and we can fill in on the table as well if we want. I'll do it in red so it's different from the other ones, because that's the one that we're adding in. Okay, but the main thing is putting in the answer slot. So this is if you're spinning it once. Bavana spins the spinner once as well. Read the question carefully. Work out the probability that will land on a 3 or a 4. So when he spins this, he's saying the outcomes he wants, we call it an outcome, what's going to happen. He's happy with getting a 3 or a 4. So the chances are going to increase of what he wants, his eventual outcome. If it was just a 3, there's only one option, it can only be a 3. But if it's a 3 or a 4 that he wants, then you're increasing the number of outcomes. So the chances go up. Okay, so the probability of getting a 3 or a 4, we just simply add these probabilities together. So chance of getting a 3, chance of getting a 3 is 0.25 from the table. The chance of getting a 4 is 0.15 from the table. So if we add them together, it's the same spin. So the chance of me getting the number I want, because I can have a 3 or a 4, is going to go up. It's going to go up to 0.4. 0.40, 0.4. Okay, it's more likely to happen. If I then threw in a 5 as well, 3, 4, or 5, there's lots of different options. So the chance is going to go up. So 3, 4, or 5 would be 3, chance of a 3, plus the chance of a 4, plus the chance of a 5. Okay, it's going to go up. And then if I add in a 2 as well, it's going to go up further, because it's more likely to happen because there's more outcomes that I desire, more outcomes that are acceptable ones that I want. Okay, remember this is only on one spin. Okay, because there's going to be different kind of ways they can ask this. So the most kind of simple types, those two. Okay, Chris spins the spinner 50 times, so very different. Work out an estimate for the number of times the spinner will land on 1. Okay, so for one spin, we know that the chance of getting a 1 is 0.36. There it is. So the chance of getting it with one spin is 0.36. If you spin 50 times, all you have to do is multiply your probability by the number of times you are spinning. Okay, the chance of getting a 1 first off is 0.36. Chance of getting it next time, 0.36. Okay, you're doing it 50 times. So 0.36, 36% of the time, it's going to land on a 1. So we want 36% of 50 times. Okay, multiply them together, and you'll get 18. So it's going to happen 18 times, which makes sense. 18 out of 50 times, 0.36. This is 36 out of 100, which is 0.36 or 36%, isn't it? Okay, but we can simply multiply that. So if you've got a particular probability and you're doing it a number of times, you can multiply those together. And this is kind of the most simple type of question. But you can see it's 6 marks. It's a lot of marks, and it's quite straightforward. Probabilities have to add up to 1 to start with. If it's an OR question, we call this an OR question because it's 3 or a 4, the chances are going to go up on one spin because you're increasing the number of outcomes that you want, desirable outcomes. So you add them together, and if you're doing it a number of times, all you do is you multiply that probability by the number of times. That's question 1. Okay, so question 2. So it's a little bit darker, but I'm sure you'll make do. So James is shooting at a target. He either hits the target in one of the 3 circles or misses the target altogether. Imagine you're firing an arrow. Here he is, terribly drawn little man. He's firing an arrow. He's going to hit it somewhere, either the middle, the inner, the middle, or the outer, or he might be terrible and he might miss completely. Okay, they're the different outcomes. So we can put this in a little table if you want to, but when he's firing, he's going to hit the outer circle. I'll just call it outer circle, 0.6. Okay, it's probably quite a big target, so he's most likely to hit that. A little bit harder to hit the middle. That's 0.2. And then the inner, or the bullseye, that's even harder still. That's 0.1. Okay, the other option is that he misses the target altogether. But we're not told what that is. Okay, so we can actually create like a little table. Just like with question 1. Okay, they don't give you the table here, but it's exactly the same kind of idea. Probability that he misses the target. Well, the only options he's got are outer, middle, inner, or miss. So if he's firing an arrow, the probability of one of those things happening has to add up to 1. So the probability of him missing is going to be 1 minus all these added together. So 1 minus 0.9, 0.1. Part B. What is the probability of James hitting the middle or the inner? Okay, again, he's still firing just one arrow. So the chance of him hitting the middle or the inner is going to increase because now he's got two different options for the same arrow. You can hit the middle, that's acceptable, 0.2 chance of that happening. Or you can hit the inner, that's also acceptable in this case, 0.1. So it's a 0.3 chance of him hitting one or the other. If he hits the inner, that meets this outcome. If he hits the middle, that also meets this outcome. So the chance goes up. We are adding probabilities together. If he fires 50 arrows, find an estimate for the number of times he will hit the outer circle. So the probability of hitting the outer circle, looks like octa, sorry, is 0.6. If he's doing it over and over again, all we have to do is multiply the number of times by that. 60% of the time, he's going to hit it. So if he's doing it 50 times, it's like 60% of 50. 0.6 times 50, and this should give you 30 times as your answer. Okay, so very similar to the first question, but it's just getting used to the phrasing, how they word it, and this whole idea that for one shot or one spin of the spinner, the probabilities have to add up to 1. So we can always find missing ones. And then this whole idea of this word or comes up again, hitting the middle or the inner circle, middle or. If it's all on the same shot, then the chance is going to go up because you've got more outcomes. What's the chance of rolling a 1 on a dice? 1 in 6. The chance of rolling a 1, 2, or 3, you've then got 3. You've got 3 outcomes instead of 1. So the chance goes up. You'll be 3 out of 6, or half chance. That's how it works.